Hello learners! Welcome to another episode of Sci-Connect. I am Teacher Jess, your science teacher for today. Are you now ready to learn? Let's start!
In real-life situations, pieces of matter are quantified by finding their mass or by counting. Market vendors, for example, would rather sell mango seeds by getting their mass and salted eggs by counting. The choice of quantifying these goods are determined by convenience. To measure these quantities, mass units such as kilograms and grams, and counting units such as dozens and pieces are being used. In today's lesson, we are going to talk about one of the most important units in chemistry, the mole. At the end of this video lesson, the learners should be able to use the mole concept to express mass of substances. Specifically, the learners should be able to first define mole conceptually. Second, determine the molar mass of a substance. And third, solve problems on mass, mole, number of particle relationships. To measure your prior knowledge, answer the following pre-assessment. Choose the letter of the correct answer. Write your answers in your activity notebooks. Submit your activity notebooks to your respective science teachers. You may pause the video if you need more time. Are you ready? Let's start. Number 1. How many particles are equal to 1 mole? Letter A, 6.02 times 10 raised to 22 particles. Letter B, 6.02 times 10 raised to 23 particles. Letter C, 6.02 times 10 raised to 24 particles. And letter D, 6.02 times 10 raised to 25 particles. Number 2. Calculate the molar mass of water. Letter A, 8 grams per mole. Letter B, 16 grams per mole. C, 18 grams per mole. And letter D, 24 grams per mole. Number 3. Which of the following units is used in expressing the amount of substance in terms of the number of particles? Letter A, Celsius. Letter B, gram. Letter C, liter. Letter D, mole. Number 4. Which statement is not true? Letter A, 1 mole of a substance contains a fixed number of particles. Letter B, the formula weight of the compound is equal to 1 mole of that substance. Letter C, 1 mole of each different substances have different masses and different number of particles. Letter D, 1 mole of each different substances have the same number of particles but have different masses. Number 5. How many molecules are there in 2 moles of water? Letter A, 2 times 10 raised to 23 water molecules. Letter B, 6.02 times 10 raised to 23 water molecules. Letter C, 12.04 times 10 raised to 23 water molecules. Letter D, 6.02 times 10 raised to 46 water molecules. Now, let us do this. What comes first into your mind when you hear the word mole? For this activity, you are going to complete the graphic organizer and write your answers inside the shapes. Third, a dozen of eggs. Fourth, ream of bond paper. And number 5,
Fifth, mole. What is a mole? It is a unit used by chemists in quantifying things that are too small and too many to count, such as atoms, ions, and molecules. A mole is also equal to 6.02 times 10 raised to 23 particles. Remember, a mole is not an abbreviation for molecule. But what is 6.02 times 10 raised to 23? It basically means 602 followed with 21 zeros. It can also be called a 602 hexillion. This number is also known as Avogadro's number in honor of the Italian scientist Amedeo Avogadro. Now let us compare mole to units we use daily. A dozen of eggs has 12 eggs. A mole of eggs has 602 hexillion eggs. Can you imagine how many eggs are there? But how big is 6.02 times 10 raised to 23? If you put together 6.02 times 10 raised to 23 basketballs, it will be as big as the Earth. Or, if you have 6.02 times 10 raised to 23 rice grains, it would cover the land masses of the Earth to a depth of 75 meters. Now, let us find out the number of particles in a given substance. Let us take this example. How many molecules are there in 4 moles of carbon dioxide? Remember that 1 mole of a substance is equal to 6.02 times 10 raised to 23 particles. To find the number of particles or molecules, let us first write down the known or the given variable, which is 4 moles of carbon dioxide. Then, multiply it with a conversion ratio of 1 mole is to 6.02 times 10 raised to 23 particles. Since we are finding the number of molecules, write the mole below. By cancelling the moles, we are left with molecules. 4 multiplied by 6.02 times 10 raised to 23 and divided by 1, then the result is 2.41 times 10 raised to 24 molecules of carbon dioxide. Now let us find out the number of moles through this example. How many moles of oxygen gas are equal to 2.709 times 10 raised to 24 oxygen gas molecules. Remember, 1 mole is equal to 6.02 times 10 raised to 23 particles. To solve for the number of moles of oxygen gas, let us first write down the known or the given variable, which is 2.709 times 10 raised to 24 oxygen gas molecules. Then, multiply it with the conversion ratio of 1 mole is to 6.02 times 10 raised to 23 particles. Since we are finding the number of mole, let us write the molecule below. By canceling the molecules, we are left with moles. 2.709 times 10 raised to 24 multiplied by 1 and then divided by 6.02 times 10 raised to 23, then the result is 4.5 moles of oxygen gas. Remember this? A mole is the name given to a very large number which is equal to 6.02 times 10 raised to 23 particles. 6.02 times 10 raised to 23 particles is also known as Avogadro's number. A mole has 602 hexillion particles. Now, let us apply what you've learned. Number 1. How many mango seeds are equal to 3.50 moles of mango seeds? Number 2. How many moles of rice grains are equal to 1.807 times 10 raised to 24 grains of rice? Remember, you may pause the video if you need more time. Explore. This activity is entitled I'm All Alone. In this activity, you are going to fill the table on the right with the atomic mass for each element with the use of the periodic table of elements. Express the mass of the elements in whole number. Was it easy finding the atomic mass of an element? Now, let us try to find the molar mass of a compound. But before that, let us first define what molar mass is. It is the mass of 1 mole of a substance expressed in grams. It is also the formula weight of a compound expressed in grams. It could also be the sum of all the atomic masses of the elements present in the compound. Second, determine the number of atoms of each element. The number of atoms are indicated by the subscript of each element or the coefficient of the compound. For this example, the carbon has 1 atom, while oxygen has 2 atoms. Third, Third, write the atomic mass of each element. You may refer to the periodic table of elements to find the atomic mass of each element. It is highly recommended to use whole number. Carbon has an atomic mass of 12, while oxygen has 16. Fourth, multiply the atomic mass with the number of atoms. For carbon, we have 12, while oxygen has 32. Fifth, get the sum of the product in gram per mole. 12 plus 32 is equal to 44 grams per mole. Note, MOL is an abbreviation of mole. And remember that 1 mole of carbon dioxide weighs 44 grams. Now, let us have another example. To find the molar mass of table salt, we must follow the step-by-step process discussed in the previous slides. Identifying the elements in the given compound, table salt is composed of sodium and chlorine. Table salt has 1 atom of sodium and 1 atom of chlorine. Sodium has atomic mass of 23, while chlorine has 35. Multiplying the number of atoms in an element to its atomic mass, sodium has 23, while chlorine has 35. Summing up 23 and 35, the result is 58 grams per mole. It means 1 mole of table salt weighs 58 grams. Now, let us try to find the molar mass of water. Water is composed of hydrogen and oxygen. Water has 2 hydrogen atoms and 1 oxygen atom. The atomic mass of hydrogen is 1, while oxygen has 16. Multiplying the number of atoms to the atomic mass, hydrogen has 2, while oxygen has 16. Summing it up, we get a result of 18 grams per mole. It means 1 mole of water weighs 18 grams.
What can you infer from the given results? That's right! Different substances with the same number of moles have different masses. Do they have the same number of particles? Of course, yes. Different substances with the same number of moles have the same number of particles. They all have 6.02 times 10 raised to 23 particles.
Remember this: molar mass is the mass of 1 mole of a substance expressed in grams. The molar mass of a monatomic element like sodium, lithium, magnesium is numerically equal to its atomic mass expressed in grams. Different substances with the same number of moles have the same number of particles but have different masses.
Now, let us apply what we've learned. Copy this table in your activity notebooks. Fill in the table with the needed information. Use the periodic table of elements in completing this table. The first one is done for you. You may pause the video if you need more time. Keep this in mind. The relationship among mass, number of moles, and number of particles is essential in chemical calculations, which is termed as stoichiometry. This is a necessary tool in obtaining the right information in terms of mass, mole, and number of particles between reactants and products in a chemical reaction. The simplest calculation to be introduced is the mole-mass relationship. This is important in interconverting the moles of the substances to its corresponding mass and vice versa. It is wise to remember that the molar mass of a substance gives the mole to gram ratio of a substance. The formula weight of the compound is the mass of the compound. To find the mass, you can use the following formula. Mass is equal to the number of moles multiplied by the molar mass of the substance. To find the number of moles, you can use moles equals mass of the substance divided by the molar mass of the substance. Let us try this example. What is the mass in grams of 2 moles of iron? To find the mass, use the following formula. Mass is equal to the number of moles times the molar mass of the substance. Substitute the number of moles with 2 moles of iron times the atomic mass of iron, which is 56 gram per mole. Note, we use the atomic mass since the given is an element. Canceling the mole, we are left with grams. 2 times 56 is equal to 112 grams of iron. Let us try another example. How many moles of beryllium atoms are there in 16 grams of beryllium atom? To find the number of moles, use the following formula. Number of moles is equal to the mass of the substance divided by the molar mass of the substance. Substitute the mass of the substance with 16 grams of beryllium times the molar mass or the atomic mass of beryllium. Beryllium is a one-atomic element Canceling the grams, we are left with mole. 16 times 1 divided by 9 is equal to 1.78 mole of beryllium. Now, let us study about the relationship between mass and the number of particles. To find mass, you can use the formula mass is equal to the number of particles times molar mass of the substance divided by Avogadro's number. To find the number of particles, you can use the formula number of particles is equal to the mass of the substance times Avogadro's number and divided by the molar mass of the substance. Let us try this example. How many ionic particles are present in 50 grams of copper sulfide? To find the number of particles, use the following formula. The number of particles is equal to the mass of the substance times Avogadro's number divided by the molar mass of the substance. Substitute the mass of the substance with 50 grams of copper sulfide multiplied by 6.2 times 10 raised to 23 and divided by the molar mass of copper sulfide, which is 96 grams. Canceling the grams, we are left with mole. We are left with particles. 50 times 6.02 times 10 raised to 23 divided by 96 is equal to 3.14 times 10 raised to 23 particles of copper sulfide. Let us try another example. How many atoms of chlorine are present in 1.70 times 10 raised to 23 molecules of chlorine? To find the mass, use the formula mass is equal to the number of particles times the molar mass of the substance divided by Avogadro's number. Substituting the given variable, mass is equal to 1.70 times 10 raised to 23 molecules of chlorine multiplied by 70 grams and divided by 6.02 times 10 raised to 23 molecules of chlorine. Canceling the molecules, then the result is 19.77 grams of chlorine. Now, let us study about the relationship between mole and the number of particles. To find mole, you can use the formula mole is equal to the number of particles divided by Avogadro's number. To find the number of particles, use the formula particles is equal to the number of moles times Avogadro's number. Now, let us try this example. A compound has a molar mass of 856 grams per mole. How many molecules are present in 2 moles of the compound? To solve this problem, you can use the formula number of particles is equal to the number of moles times Avogadro's number. Substituting the given variables, particles or the number of particles is equal to 2 moles of the compound times 6.02 times 10 raised to 23 is equal to 12.04 times 10 raised to 23 molecules. Try this other example. Element X has 128.07 times 10 raised to 23 molecules. How many moles does element X has? To solve this problem, you can use this formula. Number of mole is equal to the number of particles divided by Avogadro's number. Substituting the given variable, mole is equal to 128.07 times 10 raised to 23 molecules divided by 6.02 times 10 raised to 23 particles is equal to 21.27 moles of element F. To summarize the relationship among mass, number of moles, and number of particles, you have to remember this general pattern in solving stoichiometric problems. Now, let us apply what you've learned. Copy this table in your activity notebooks. Fill in the table with the needed information. Use the periodic table of elements in completing this table. You may pause the video if you need more time. Now, try to reflect on this lesson by completing these sentence prompts. Write your answers in your activity notebooks. I have learned that. I wish to ask my teacher about. Now let us assess your learnings through this post-test. Choose the letter of the correct answer. Write your answers in your activity notebook. Remember that your notebooks will be checked and collected by your respective science teachers. Number 1. How many moles are contained in 34 grams of ammonia? Letter A, 1 mole. Letter B, 2 moles. Letter C, 17 moles. And letter D, 34 moles. Number 2. Which of the following refers to the mass in grams of a mole or a compound? Letter A, mole. Letter B, dozen. Letter C, molar mass. Letter D, Avogadro's number. Number 3. Which of the following units is used in expressing the amount of substance in terms of the number of particles? Letter A, Celsius. Letter B, gram. Letter C, liter. Letter D, mole. Number 4. Which statement is not true? Letter A. 1 mole of a substance contains a fixed number of particles. Letter B. The formula weight of the compound is equal to 1 mole of that substance. Letter C. 1 mole of each different substances have different masses and different number of particles. Letter D. 1 mole of each different substances have the same number of particles but have different masses. Number 5. How many molecules are there in 2 moles of water? Letter A. 2 times 10 raised to 23 water molecules. Letter B. 6.02 times 10 raised to 23 water molecules. Letter C. 12.04 times 10 raised to 23 water molecules. Letter D. 6.02 times 10 raised to 46 water molecules. Number 6. Calculate the molar mass of water. Letter A, 8 grams per mole. Letter B, 16 grams per mole. Letter C, 18 grams per mole. And letter D, 24 grams per mole. Number 7. How many molecules are there in 72 moles of hydrogen atoms? Letter A. 6.02 times 10 raised to 23 molecules. Letter B. 12.04 times 10 raised to 24 molecules. Letter C. 4.3 times 10 raised to 25 molecules. And letter D. 6.02 times 10 raised to 46 molecules. Number 8. What is the mass of 4.39 mole of sodium? Letter A. 27.3 grams. Letter B. 55.2 grams. Letter C. 101 grams. And letter D. 191 grams. Number 9. Which statement is correct regarding the molecule of water? Letter A. 1 mole of water has 18 particles. Letter B. 1 mole of water contains 6.02 times 10 raised to 23 particles. Letter C. 1 mole of water contains 18.06 times 10 raised to 23 particles. And letter D. 1 mole of water is equal to twice its smaller mass. Number 10. Which statement is correct? Letter A. 4 grams of ammonia is equal to 1 mole of ammonia. Letter B. 4 grams of ammonia is equal to 4 moles of ammonia. Letter C. 4 moles of ammonia is equal to 17 grams of ammonia. And letter D. 4 moles of ammonia is equal to 68 grams of ammonia.
Congratulations, learners, for finishing the video lesson. I hope you enjoyed learning with me today. Remember, learning is fun with Sci-Connect.